Let us discuss diffusion in solids. Okay, actually, diffusion refers to the movement of atoms. Let us consider a solid bar constituted by many atoms. Okay, so the movement of atoms means related to their neighbors, the atoms move from their initial position to some other positions. Okay, so when the atoms move from one position to another position, actually the flow of mass happens. For this process to happen, thermal energy is necessary. Okay, with that thermal energy actually excites these atoms, and that will give energy to the atoms to move from one position to another position. Okay, and with this thermal energy, due to electric, magnetic, or stress or concentration gradient, will be the cause of the flow of atoms. Okay, so that means if we are considering concentration gradient, actually gradient means the change of that quantity with respect to the position. Okay, with respect to moving in some direction. So if it's concentration gradient, let us consider this solid bar itself. Actually, these atoms move within this solid. So if the concentration of these atoms is more in this side, and the concentration is less when we are going to this side, then the flow of atoms will happen. Okay, then the flow of atoms will happen. That is the flow of mass will happen. So not only due to the concentration gradient, actually concentration gradient means the change in concentration while we are going in some particular direction. Okay, not only the concentration gradient, actually electric, magnetic, or stress gradient will be the cause of the flow of these atoms or flow of the mass. Okay. So here we discuss Fick's first law of diffusion. There are two laws about diffusion: Fick's first law and Fick's second law. Okay, this is the first law of diffusion. This J is equal to minus d into dc by dx. Okay, d is known as diffusivity, and c is the concentration. So this is concentration gradient. dc by dx is the concentration gradient, and this is the mass flux. Okay, J is the mass flux. And concentration, we usually, the unit of concentration in kilogram per meter cube or mole per meter cube usually represent. Okay, so this is the mass flux. Mass flux means flow of mass per area in a interval of time. Okay, this is mass flux. So mass flux is equal to minus d into dc by dx. Okay, actually this is the concentration gradient, and this quantity is negative quantity. Okay, that's why this minus sign comes here. This dc by dx is concentration gradient, and this is a negative quantity. Okay, so while we are going in x direction, the concentration x direction, if this is the solid bar, then the concentration of particle will be more here. So if we are going in x direction, the concentration decreases. So that's why dc by dx is a negative quantity, and with that negative quantity, if we multiply with this negative sign, then we will get a positive quantity. That is the mass flux. Okay, so flow of mass is a positive quantity. So this is the Fick's first law. J is equal to minus d dc divided by dx. Okay. This is the diffusivity. D is equal to d naught e raised to minus q or RT. Actually, diffusivity is highly temperature dependent, and d naught is a pre-exponential factor. R is the universal gas constant, and gives the activation energy required for that atom to jump from one position to one equilibrium position to another equilibrium position, and T is the absolute temperature. Okay. Let us discuss Fick's second law. Okay, for that, let us consider a solid bar lying in x direction, x axis, and this is the point x, and this is x plus delta x. When we are considering the solid bar, a small volume delta V lies in between x and x plus delta x. Okay, so the concentration is more in this side, and the atoms will move in that direction, x direction. Okay, so while that atoms move from this side to other side, the atoms enter in the small volume. Some of the atoms enter the small volume, and some of the atoms leave from that volume. Okay, so mass entering volume delta V at x in time interval delta t. We are considering a small time interval delta t. Within that time interval, the mass entering volume mass entering into the volume delta V is mx is equal to jx into a delta t. And we know the definition of the mass flux. Jx is the mass flux. Jx is equal to mass per unit area in a time interval. So we can define this mass entering into the small volume delta V is mx is equal to entering into this delta V at x is mx is equal to jx into a delta t. Okay, so mass leaving delta V at x plus delta x, mass leaving at x plus delta x from delta V, small volume delta V in time interval delta t is mx plus delta x is mass flux jx plus delta x into area of cross section into delta t. Okay, so we need to find out the mass accumulating in this volume. Mass accumulating in delta V in delta t time interval is delta m is the mass accumulating, that is equal to mx the mass entering into the small volume minus mass leaving from that small volume delta V. Okay, that is mx minus mx plus delta x is equal to jx into a delta t minus jx plus delta x into a delta t. So we can take this minus sign outside and we can write like this: jx plus delta x minus jx into this is also common, a into delta t, time interval and area of cross section is constant for this solid bar. So area into delta t, and that is equal to minus delta j. This is the difference in mass flux. Minus delta j is the difference in mass flux, change in mass flux, and that minus into delta j into a delta t is equal to the mass accumulating in small volume delta V in the time interval delta t. Okay, so concentration change in delta V in delta t time interval is delta c is equal to mass per volume delta m over delta V is equal to, we got delta m here minus delta j into a delta t. So minus delta j, a delta t over a into delta x is equal to the area will get cancelled, a and a will get cancelled, that is equal to minus delta j over delta x into time interval delta t. Okay, the concentration, change in concentration with respect to the time is delta c over delta t is equal to minus delta j by delta x. So if we apply limits on both sides, then we will get limit delta t tends to 0, time interval tends to 0, delta c or delta t is equal to minus limit delta x tends to 0, delta j over delta x is equal to, that implies dou c over dou x. This left side is dou c over dou x, that is concentration gradient, that is equal to minus dou j by dou x, where j is the mass flux. Okay, this is flux, this is Fick's second law. Okay, dou c, the concentration gradient is equal to decrease in change of mass flux with respect to the distance. So here one mistake happened. So this is dou c by dou t. Okay, limit to delta t tends to 0. Dou c by dou t, delta c by delta t is dou c by dou t. Okay, so we know from Fick's first law, the mass flux j is equal to minus d dou c by dou x. So we can apply this value in this equation. We will get another form of this Fick's second law, that is dou c by dou t is equal to minus dou by dou x of, instead of j we can apply d dou c by dou x. So this is dou c by dou t is equal to minus d into dou square c over dou x square. This is another form of Fick's second law. This is a Fick's second law, dou c by dou t is equal to d dou square c by dou x square. Okay, solution of this kind of equation has a general form. C is equal to a minus b error function of x over 2 under root dt. Okay, this a and b are constants. We can find a and b, this constants, by applying boundary conditions. Okay, and this is error function. ER represents error function, Gaussian error function. Okay, and let's discuss what is Gaussian error function. This is a function, error function of z is equal to 2 over under root pi integral 0 to z e raised to minus y square dy. This is Gaussian error function. Okay, from this graph we can explain this. This is a graph of y versus e raised to minus y square. Okay, it's a Gaussian function, and look at this. If this point is z, then this area, okay, we can represent this area, we can find out this area by integrating integral 0 to z e raised to minus pi square dy. Okay, So this is integral 0 to this area is integral 0 to z e raised to minus y square dy, and error function of z is equal to 2 over under root pi into this area. Okay, and some of the properties I am introducing here. Error function of 0 is equal to 0. Error function of minus z is equal to minus error function of z. These are the characteristics. Error function of infinity is equal to plus 1. Error function of minus infinity is equal to minus 1. Okay.